Dear students, yesterday we studied about different types of correlation, and today we are going to discuss about different methods of studying correlation. While analyzing the relationship between two or more variables, two things are very important. One is the direction of change in the variables, that is whether they are moving in the same direction or in the opposite direction. And the second is the degree of relationship between the variables. For studying these two aspects of correlation analysis, different methods are used, and all these various methods can be broadly classified into two categories. One is graphical methods and the other is algebraic methods. Algebraic methods are also called mathematical methods or statistical methods. Under algebraic methods, there are two methods. One is scatter diagram method and the other is correlation graph methods. Similarly, algebraic methods may be of three forms. One is Karl Pearson's coefficient of correlation, second is Spearman's rank correlation method, and the third one is concurrent deviation method. Now let us see the first graphic method, that is scatter diagram method. Scatter diagram method is the simplest method of studying the relationship between two variables. One variable is shown on the x-axis and the other is shown on the y-axis. Each pair of x and y variable values are shown on a chart in the form of dots. When all the pairs of values are shown in the chart, it is called a scatter diagram. Since we show dots in the scatter diagram, it is also called datogram or dot chart. The relationship between the variables is measured by observing the manner in which dots are plotted. It explains both the direction and degree of relationship. Let us see how to interpret the relationship between variables with the help of scatter diagram. See this scatter diagram. What about the direction of change in the variables? Can you identify the movement of plotted dots? The direction is from left bottom corner to the right upper corner. Okay, this denotes both the variables are moving in the same direction. Okay, then what about the degree of relationship? Here all the dots are lying as points on a straight line. This means the correlation is perfect correlation. So we may interpret that this scatter diagram shows a perfect positive correlation between variables. Okay, see the next diagram. Here the direction is from left upper corner to the right bottom corner. This means the variables are moving in the opposite direction. Okay, and all the dots are plotted as points of a straight line. Therefore, it is a perfect correlation. So, we may interpret this scatter diagram as a perfect negative correlation. Clear? See the next one. Here, the movement is from left bottom corner to the right upper corner. Therefore, the direction is positive, but the dots are not lying on a straight line. However, they are lying on a narrow width. Okay, that is there is high degree of positive correlation. See this diagram, this scatter diagram. Here the direction is negative, that is from left upper corner to the right bottom corner. The direction is negative and all the points are lying on a narrow band. Therefore, this scatter diagram interprets that there is high degree of negative correlation between the variables. See another case. Here the direction is positive, that is moving from left bottom corner to the right upper corner. But all the points are lying on a wide width, okay, wide band, not narrow or not a straight line, not on a line or not within a narrow band. All the points are lying in a wide band. Therefore, this is the case of low degree of positive correlation. Okay, see this one. Here the direction is negative, okay, and all the dots or all the points are lying in a wide band, wide width. Therefore, this is the case of a low degree of negative correlation. Okay, see another one. Here all the points are lying in U shape. Okay, here it is not possible to identify even the direction of the change. Therefore, it is the case of no correlation or zero correlation. Here also it is unable to identify the direction and degree of relationship. Therefore, this is the case of no correlation. Okay, see another case. Here all the points are lying on a perpendicular to the x-axis. This means that x remains constant at different y values. Y values are different but x remains constant. Okay, that means this is zero correlation. Here also a zero correlation case. Here the points are lying on a line parallel to x-axis. This means y remains constant at different values of x. At different values of x, y remains constant. Okay, and this is a case of zero correlation. Okay. Let us see the important merits of scatter diagram. First merit is that scatter diagram is the simplest method of studying correlation between two variables. Second is, as scatter diagram is very simple to understand, it gives a clear idea about the nature of correlation even to a common man. Thirdly, it does not require mathematical formula or complicated calculations. Lastly, since mathematical formula are not used, it is not affected by extreme items. Okay, these are the important merits of scatter diagram. Then let us see the important drawbacks, demerits of scatter diagram. The first drawback is that it gives only a rough idea about the relationship exists between variables. Second is, under scatter diagram we have no numerical measurement to interpret the degree of relationship more accurately. Lastly, scatter diagram is not suitable when there are large number of observations. These are the important limitations of scatter diagram. Okay, let us wind up today's class. If you have any doubt, ask me about it. Okay, thank you.